Okay, special growth and decay periods. I kind of sectioned these off because I briefly talked about them, and they act very special, and they're very different, and there's something else to take into account. In our notes, we called these half-life questions, and they were on the day with basic applications. So a radioactive substance has an initial mass of 100 grams. We know that it's always initial, whatever the growth is, T to whatever, okay. But what the extra part here is, let's put amount equals. The mass halves, meaning we get half of it, right, cut in half, so 1 minus a half is a half, so 1/2, okay, so 1 minus 0.5. But it says every 4 years, not every year. So if we have another time period, we divide T by that number, a half-life or a double life or a triple life or whatever you want to call it. So every 4 years. Which of the expressions shows this equation? Well, that would be choice 3. Yeah? Beautiful. Okay. The New York Volleyball Association invited 64 teams, so there's our initial value, to compete in a tournament. After each round, half of the teams remained, or were eliminated, so 1 minus a half is a half. Which equation represents the number of teams that remained in the tournament after R rounds? So T should be R. So 64, 1/2 to the R is choice 4. Okay, number 3. A bacteria doubles. That means increases by 100%. So in our parentheses, we have 1 plus 100% is 1. So in our parentheses, we have a 2. And it says every 15 minutes. So this isn't every 1 minute or every 1 hour or every 1 year. So it's T divided by 15. Given a starting population of 100 bacteria, got it, how many bacteria are present after 4 hours? So our equation is B of T equals 100 initial, 2 because it's doubling, 1 plus 1 is 2, every 15 minutes. Now, the secret, sneaky trick here is that this is hours and this is minutes. I'm going to change 4 hours is 4 times 60, so 240 minutes. So B of 240 is equal to 100 times 2 to the 240 over 15. So let's go here. 102 to the 240 divided by 15. Ooh. What's that? 6,553,600. Yeah, it was it's bacteria, so there's a lot of them. Gross. I never want to do anything ever anymore. It's probably bacteria. Gross. Okay, wash your hands, kids. Wash your hands. All right. Drew's parents invested $1,500, so we know that's our initial amount, in an account such that the value of the investment doubles every 7 years. You see that? So, increases by itself, increases by 100%. So our base is 2. But every 7 years means T divided by 7. How many years to the nearest tenth of a year will it take for the value to reach 1 million? So our initial is 1500 equals 1 million. Okay. Step 1, pretty much every exponential equation is divide. Get the weird thing alone. So 1 million divided by 1500. I'm going to use my calculator. 1, 2, 3. 1, 2, 3. Divided by 1500. 2,000 over 3. I'll write that instead. Okay. 2,000 divided by 3 is equal to 2 raised to the T over 7. I got the exponential part alone, so now I can change the form. Log base 2 of 2,000 divided by 3 is equal to T over 7. My last algebraic move is to multiply both sides by 7 and then go to my calculator. So 7 log base 2 of 2,000 over 3. 65.66. What are the rounding directions? Nearest tenth of a year. So t equals 65.7 years. All right. Beautiful.